Welcome to our classroom. Welcome to the classroom. Welcome to the classroom. The segments where I bring the classroom out into the field to teach you about geological processes. Welcome to the classroom. Today we're talking about earthquakes, and I've made an earthquake simulator.
Wow!
All right, so I've got two uprights that I've made out of Lego and a cardboard sheet across here. I've drawn rings out from the center building here, and the buildings are just constructed with blocks from my kids' toys. And we have got similar buildings here and here. The foundation on this building is a bit wider than those two, but a similar construction. And an earthquake happens when a fault slips. Faults can be deep or they can be shallow near the Earth's surface. But what happens when that fault slips is it sends a shock wave out from that location, which is the focal point. That's the place where the slip happens. And then we have a place on the surface of the Earth called the epicenter, where the wave first hits the surface of the Earth. And that's underneath this building here. And I can tap this board and you can see it vibrate, simulating an earthquake. It's very rudimentary, but you could build this at home and play around just to learn a little bit more about earthquakes and how to construct your block buildings. So that's what I want to try to do, is do a small earthquake, many vibrations, because an earthquake causes lots of vibrations, and see the difference in the behavior of the buildings as distance away from this building here, which is at the epicenter. So let's give it a try and see what happens. So very light shaking. We see things wobbling. So you can see some separation in the middle layer of this building, and this one's still intact. The top block is shifting slightly. First building collapsed. Oh, the middle building's collapsed. Now the outer building, but you see the foundation of this building, the blocks are still together where there's separation happening here. You can see these three columns, oh, that one fell down, vibrating. So some buildings we can build tall buildings and still have them withstand the earthquake more so than other buildings in the same vicinity. There we go, everything is collapsing. So there you have it, earthquake simulator you can construct at home. We see that the buildings closer to the epicenter have a harder time. They are collapsing sooner than ones further away from the epicenter. And that's the engineering link. We have to design our buildings in places that are prone to earthquakes in order to withstand the ground motion and not have the buildings collapse. And we'll talk more about that in class, but that's the engineering link. Thanks for watching this video, and I look forward to talking more about this in class with you. We see things wobbling, a little bit harder. You can maybe see, oh, the top fell off of that one, but the middle building, the blocks are actually separating apart. I see a little bit of that on this building here. No, that one's collapsing. So different behaviors for the different buildings. There we go. But you can see actually a lot of separation on this building compared to this building. Although the top fell off of this one early,